Hey, it worked. Okay, nice. So I'm just writing out the third degree Taylor polynomial. There's the function. There's the first derivative of the function. And if you do out the Taylor polynomial, this is what you end up with. Now, that was the first stage of what we did in 10.1 and 10.2. What can you use the Taylor polynomial to do? What can you use that theoretically to do? That's an estimate for the values around 0. So you can plug in x values and get estimates for the original function value. So theoretically, if we wanted to estimate, everybody, if we wanted to estimate 0.5 to the 1/3, what would we plug in for x here? What would we plug in? 0.5. Because what makes this thing 0.5 to the 1/3? It just happens that you plug in 0.5 to turn this into 0.5. Is that always true?
Yeah.
Could I make that, let's say that was 2. Could I turn that into a 2 and do a different derivative? Yes. You can use different functions to evaluate the same number. If that was a 2, what number would I be plugging in for x? 1.5. I'm just pointing this out. This is really important. It's 0.5 because 1 minus x needs to equal 0.5, so therefore x has to be 0.5. It's just a coincidence that you're plugging in the same number. Okay, so theoretically, could we plug that in? Absolutely. So what are we doing here? We're trying to find E3. Why is it E3 and not E4? Why is it E3 and not E4? What does the question ask us to find? Use the third degree Taylor polynomial. So n is what? N is 3. N is 3. So what are we trying to do? We're trying to find an estimate, not an estimate, an upper bound. We're trying to find an upper bound for the actual error. This is the actual error right here. But here's the thing. We're trying to find a maximum because theoretically, we don't know how to do this part. We don't know how to evaluate the actual function. So we're trying to find this bound. Well, n is what? What was n? 3. What goes down here? N plus 1 factorial, and it's around 0, and it's the x value of 1/2 to the 4th. So again, this is a quest just to find what? Just to find what? M. It's just to find M. It's just to find M. So we're not there yet, so we're just trying to find M. Yes, Papa Sam?
What?
Let's do it, and then you'll understand, theoretically. So, what is M? What was that definition, Seema, that you were so proud of remembering? M. What is M? Don't look down.
M
Yeah.
over.
Well, this is M over, yes. Yep.
N plus 1.
Yep.
Factorial.
Yep.
Absolute value x minus a.
To the.
To the n plus 1.
And what is that greater than or equal to?
The f of x minus the.
Well,
Or not the Taylor minus the Taylor.
Oh, so you're doing the whole thing here. Sorry. Yes. Got it. So you'd had what? F of x minus. Yes. Like this, right? So M, just M right there. What was that greater than or equal to?
Oh, the f, like the derivative of the n plus 1.
The n plus 1th derivative, right? On what though? This is on the what? On the interval. So the interval. So you have to know an interval, and you're looking at a function which happens to be the n plus 1th derivative. What's the function we're looking at right here? It gives us the function. What is it? Hey, look, you see it right there, everybody? Everybody sees the function? So what are you going to have to do with that function? Find the what derivative? Find the 4th derivative. So let's do that right now. What was the function? It was f of x was 1 minus x to the what power? 1/3. So what's f prime of x? 1/3, 1 minus x to the what power? Negative 2/3. So f times what? Oh yeah, times what? Negative 1. So f double prime of x, what's that going to be? 1/3 times negative 2/3 times 1 minus x to the what power? Negative 5/3 times negative 1 squared. What's f triple prime going to be? 1/3. I'm not simplifying anything. Times what? 1 minus x to the negative 1 to the 3rd. Why am I not simplifying? Just to keep the pattern going and not to make simple mistakes. I'll simplify at the end. So what's the 4th derivative going to be? 1/3, negative 2/3 times negative 5/3 times negative 8/3 times 1 minus x, negative what? Negative 1 to the 4th. So what can we knock? We don't care about that one, right? And then how many negatives do we have out front? So we have negative, and do some things cancel here? Well, it's just going to be negative 1/3 times 2/3 times 5/3 times what? Times 1 minus x to the what? Are we okay with this so far? Are we okay with that? Can we put the fractions together now? What's the numerator become of that fraction? It's negative 80. Of 81. Oh, that's kind of nice. To the what? Negative 11 over 3, right? Okay, so we are estimating it around what value? Around 0? Around 0, but what are we trying to plug in for x? We want x to be what? We want x to be a half, right? So our interval must contain what? Must contain 0.5. So what's the smallest interval we can use that contains 0.5? So what's our interval going to be? From what to what? We can go from 0 to what? To 1/2. Yeah, just say 1/2. It's okay, 0.5 is fine too. There's the interval we're going to use. So what function are we looking at? We're looking at this function right here. And we're trying to find what's the biggest value it can be on this interval right here.
So the only requirement for the interval is that it contains...
If you want to find the maximum of something on an interval, you've done this literally hundreds of times, right? What do you do to find the maximum of a function on an interval? What do you look for first? You've literally done it 100 times. What do you look for? Say it with passion and confidence.
The critical point.
Look for critical points. So you are trying to find the maximum of this function on this interval. So you test to see if there's any critical values on that interval, and then you also test the what? The endpoints. I know for a fact that Mr. Whipple had you do that thousands of times. That's hyperbole, but I know you've done it many times. When you're trying to find the maximum value on an interval, you try to find if there's any critical values, and you also test the endpoints, right? You also test the endpoints. So what should we take of this? What do we actually need to find now if we're searching for critical values? Yeah, let's find the fifth derivative right here. Let's find the fifth derivative. Not that bad. It turns into what? 11 over 3 times 80 over 81. Why did I drop the negative sign? 2 negatives, right? Times what? 1 minus x to the negative 14/3 times what? Negative 1. So what do I end up with? Negative of 11 times 80 over 3 times 81 times 1 minus x to the negative 14/3. How did you search for critical points? What did you do with this now? You set it equal to what? You set it equal to 0 so you could search for critical points, right? So how do you make this 0? Well, this has to be 0, right? Is that possible? Really?
No, because x has to equal.
Hold on. I'm asking, answer the question without regard to the reality that's outside of that question. Is it possible to make that equal 0? Well, here's the thing. What is this equal to? This is 1 over what? 1 minus x to the what? 14 over 3 equals 0, right? Can you make that equal 0? No. No. So, no. The answer is no. So I could say, yeah, no answer to this, right? So are there any critical points? No, there aren't any critical points. So this either strictly goes up in that interval or strictly goes down. It doesn't go up and down, because if it went up and down, the derivative would be 0 somewhere in there. So what do you still have to test? The endpoints. Test endpoints. You test the endpoints. So you test the endpoints of the fourth derivative here, right? Everybody sees that right there? So let me take this here. So if we take this with the highlighting, that's nice. What are the endpoints of our interval we're testing? X equals 0 and x equals a half. So plug in 0, what do you get? You end up with negative 80 over 81 times 1 to the negative 11 over 3. What do you end up with? Negative 80 over what? 81. So let's do the next one. Negative 80 over 81 times 1 minus a half to the negative 11 over 3. You have to be very, very careful about this. So what do you end up with? Negative 80 over 81, 1/2 to the negative 11 over 3. What does that equal? Well, that's negative 80 over 81 over what? 1/2 to the 11 over 3. Do you agree with that? 1/2 is 2 to the what power? So this is the same thing as negative 80 81 times 2 to the what power? 11 over 3. So which one of these is going to be, so we said, oh man. Right there?
So 2 times.
So what do? You're actually taking on the math we just did, you're taking the absolute value of these things. So which one's bigger? So this one is bigger right there when you plug in 1/2. When you plug in 1/2.
So then you plug that in for n.
Okay, so now we found out that the maximum occurs. So the max happens when what? When x equals 1/2. The max happens when x is equal to 1/2. So you go back and let's look at this statement here. It is on that interval. So what is the maximum value when you plug in 1/2? What is the maximum value when you plug in 1/2 of the nth plus 1 derivative? What was the nth plus 1 derivative? This is the nth plus 1 derivative, right? So we need to do f4 at what value? At half, yeah, at 0.5. What's that going to be? Negative 80 over 81 times what? 1/2 to the negative 11 over 3. And if you want to make that look a little better, what do you get? Negative 80 over 81 times 2 to the what?
And that's your m
That
value.
would be your m value right there. This would be your m value. So now we can go back to the work that's over here that I wrote in. If I can actually use my finger here instead of my callus, where is it?
So m is just
a maximum on that interval. The maximum of the nth plus 1 derivative on that interval. So look, did we agree right there? Last year we came to the conclusion it happens when x is equal to 1/2. Do we agree with that? It does. So what did we plug in? Oh, look, here it is. So what was that expression? It was m over what? It was m over what? N plus 1 factorial. The x value was 1/2. This right here comes out to this. If you do this on your calculator, right there, it comes out to this decimal. So that's the maximum error right there. That's a lot of work. Yes?
so you still need to use 3 decimal places.
Yeah, I mean, the thing is, it all depends on, tell you what, it all depends on what the question is asking and if it's a multiple choice question. Usually, everybody, just to be clear here, Seema, on the AP exam, when they ask you to find what is the maximum error, it's going to be less fraction intensive than this. Why is this a really annoying answer to get in terms of, just I'll ask, why is this a really annoying answer to get? This point, it's 11, the 11 over 3 power is what makes it nasty. Why? Can you do that without a calculator? No, you really can't. You really can't. So what they tend to do is they tend to round up a little bit sometimes, and they say something like, the maximum error has to be less than one of these, right? And like 11 over 3 is really close to what? 12 over 3, right? That kind of thing. So anyway, the point being, usually you don't see numeric manipulation this complicated on the AP exam. Do you understand the process, though, that we went through? Is it a lot to keep track of? Yeah, it is. It really is. If you memorize the formulas, though, you'll be good. Put everything away except the pencil. Question for you. So when it's asking you for f6 of 0, like at the beginning of class, what's the way not to do that? Do not build the don't do it. Don't do it. You know that, where does that exist in the Taylor polynomial? That over 6 factorial x to the 6th, right? So what do you find? You find something x to the 6th by building it, and then you take this and you set it equal to that, and then you can find the 6th derivative evaluated at 0. Don't do 6 derivatives of that thing. No, don't do it. Don't do it. Build it. You'll have a chance to correct this on your own. This is all AP questions, by the way. These are directly from an AP test. So let's take a look at another one directly from an AP test. Let P4x be the 4th degree Taylor polynomial. 4th degree Taylor polynomial for f about x equals 0. Using information from the graph, show that this thing is less than 1 over 3,000. What is this thing? What does this represent? Can someone tell me what does that represent? E what? That's E what? E4. That's E4 at 1/4. That is E4 at 1/4. So you're trying to show it's less than 1 over 3,000. This is not a calculator section. So if you ever end up trying to do 2 to the 11 over 3, turn around. Everybody, stop taking your surfaces out. Just watch for now, okay? You're going to get all these notes, and I want you to watch this. So you know the formula for finding that max. You know that this thing has to be less than or equal to m over what? What's the formula? n plus 1 factorial
Absolute value of x minus a
to the,
n plus 1.
and we know that in this case n is equal to what? What is n equal to?
4.
I highlighted it for you. What is it?
4.
4. Exactly. And what is a equal to? 0. So already we can simplify it down to m over what? 5 factorial x to the, and we're doing it for what x value? X equals what? 1/4. Act with confidence. And so we're now at this. M over what? 5 factorial 1/4 to the what power? 5th. And now we're just, again, in our quest for what? M, our quest for m. And we know that m has to be greater than or equal to what? The what? No, n is what? N is 4, so it's going to be, what's 4 plus 1, everybody? The 5th. On what interval? Well, around 0. Around 0. So it has to contain what? It has to contain 1/4. It has to be around 0 to contain. Oh, look, what do they give you the graph of right here? They give you the 5th one, right? Correct? So when you're looking at this right here, on this interval, let's say from here to here, let's look at that interval. On that interval right there, what's the greatest, the 5th derivative? What is it definitely less than? This right here is the 5th derivative right here. What is it definitely less than from, let's say, 0 to 1/4? 1/4 is right there. What's it definitely less than? 40. It's definitely less than what? Did you say, Chaiwat? 40. Does everybody see why it's definitely less than 40 from 0 to 1/4? Because where is it? Look at that. This is the point, what? 1/4 less than 40. Do you agree? So we could choose what for our m value? We could choose 40 for our m value. We could choose 40 for our m value. So let's say m is equal to 40. Are you okay with me choosing 40 for that?
That's the maximum.
Because on the interval from 0 to 1/4, here's 1/4, here's negative 1/4, and here's what? Positive 1/4. On this interval from right here to here, see the blue I'm highlighting? All of that is definitely less than what? 40. It's definitely less than 40. Do you agree with that? So let's go back and plug that into our expression. What was it? 40 over 5 factorial times what? To the what? To the 5th. So let's simplify this a little bit. What is 5 factorial? 120, right? And this is 1/4 times 1/4 times 1/4 times 1/4 times what? Do you agree with that? Can we cancel some zeros? Those go away, right? Can I cancel one of these 4s? So what do you end up with? 1 over 12 times what? 4 to the what? 4 to the 4th. Now, do you have to do a little bit of math here? Like a tiny bit? Tiny bit? What's 4 to the 4th? 4 to...
16 times 4.
Which is what?
256.
You need to know your powers of 2, everybody, right? 256. You should be able to handle this on your own without a calculator. So then if you want to do this right here, what is that? That's 2560 plus 2 times 256. What did I just do there? I'm showing you what I do in my head when I do. Yeah, what is 12? 10 plus 2. So I did 10 times it and 2 times it. So what is that? 2,560 plus what? 512. Oh boy. So what do we end up with? 3,000 what? 3,072? Oh wait, what were we supposed to show it's less than? Oh wait, we just showed the maximum 3,000. Oh, what's going on here? Are we really, really close? It's bigger than 3,000, so that's wrong, right? But here's the thing. If we're trying to show it's less than 1 over 3,000, what's less than that? 3,072, which is greater than our E4. So did we just show that? Did we just show what they asked you? Absolutely. Remember what I said about rounding and picking nice numbers? If you get a Lagrange error bound on a non-calculator section, is that a great thing? it's better than getting a calculator one because it means that all of this has to be done by what? By hand. By hand. So when you're picking an m value, you pick a least upper bound, but you need to pick a least upper bound that you can actually manipulate. Because look, you have to show, oh, it's got to be less than this thing. We just proved it's a little bit less than that. How much sense does what we just did make to you? 5, 4, 3, 2, 1, negative. You want to leave? You're still not sure?
It makes
Can I get a
sense
3
when
and a
we do it.
Yes.
I'm just not confident that
Absolutely. That's totally.